Hello, students. So let's try to solve one more problem from JEST 2022. And this is a very nice problem. And this problem is from quantum mechanics. And the concept is actually Pauli exclusion principle. So what is this problem? So there is a box and this is infinite box of width d. And we have to adjust 8 electron. So we have to adjust 8 electrons. Then we have to find ground state energy for the configuration after adjusting the 8 electron. So we all know for the single particle system, the En can be written as n square E naught, where E naught is pi square h cut square upon 2m d square. And n is the allowed quantum number. So that is 1, 2, 3, and so on. And when we include the spin of a particle, hence electron is fermions. So here Pauli exclusion principle will allowed. So in each and every quantum state, there is only one fermion can be allowed. And due to spin half particle, each energy state can be further divided into two extra quantum state due to quantum number plus half and minus half. So let's see what is going to happen. So for n is equal to 1, we have energy eigenvalue E naught, and this can be, if we are including the spin, this can be divided into two level, that is spin half and spin minus half, and one electron can be adjusted in each level. So this is my quantum number. So similarly, for n is equal to 2, the energy eigenvalue is 4 E naught, and this can be again bifurcate into spin half and minus half. So this is again 2 electrons are there. So 4 is adjusted. Now for n is equal to 3, the energy eigenvalue is 9 E naught, and this can be given as again, this will be half and minus half. So 6 electrons have been adjusted. And now n is equal to 4. So this is 16 E naught. And we have basically again spin half and minus half. So total 8 electrons have to be adjusted like that. And electrons are indistinguishable. So you cannot say this is my first electron and this is my second electron. Only thing we have to count is the at least one quantum number should be different for each and every quantum state. That is Pauli exclusion principle in another way. So and now this is the configuration for ground state. This is the minimum energy when we are putting this 8 electron. So what is this particular energy? We are going to sum it off. So the energy is E naught plus 16. So 2 times E naught. So everywhere 2 is there. So 2 times E naught and 4 E naught plus 9 E naught plus 16 E naught. So this is single particle energy level, and we are multiplying with 2 because in each and every level there are 2 electrons. And we have also assumption that these electrons are not going to interact to each other. Okay, so this is the very ideal kind of assumption is there. So if we can take it, so there will be E naught into 2, this is this 2, and we have 16 plus 9 is 25 plus 5 is basically 30. So this is my energy eigenvalue. So now we have to put the value of E naught. So that will be 60 into pi square h cut square upon 2m d square. But in the problem, the option they have given in term of h. So we have to just write the value of h cut as h by 2 pi. So this is 60 into pi square into h square by 4 into pi square into 2m d square. So this pi square is cancelled. So we have this is basically 15. So we have 15 h square by 2m d square. So this is option and this is the answer. So every in this point you have to little bit careful, otherwise you can mark the wrong answer. Otherwise, this is very conceptual question. How to use Pauli exclusion principle, we can learn from this particular problem. Thank you.